Hey everyone, my name is Matheus and welcome back to the channel after more than a year. I'm sorry for not showing up for so long, but I had a lot of things to do. The thing is, I am back and with a very interesting topic so we can talk about today.
Okay, today we're going to talk about a very common problem that always shows up in technical interviews. And it's called the two-sum problem. In this problem, we're going to receive an array with integers, and we're also going to receive a target. And our goal here is to find two numbers inside this array that when we sum them, we're going to get the target. There are two important details in this case. First one, we cannot sum the number to itself, so we cannot use it twice to get to the target. And the second point, we know there's going to be exactly one pair of numbers inside the array that's going to sum to the target. First of all, I'm going to show you a visual approach. We're going to draw it all together so we can have a better understanding of the problem. And after, we're going to try the code approach. We're going to run it on LeetCode and all, so we can see if our approach is going to be good or not. Okay, so stick up with me. Okay, so now I'm going to show you the visual approach so we can have a better understanding of the problem to think about the possible approaches. I'm going to show you here two possibilities we have to solve the problem. The first one is gonna be not is not gonna be very efficient. The second one's way is gonna be way better. Okay, so let's pretend here we have an array called nums. Okay, and inside this array we're gonna have full integers. We're going to have 11, 15, 2, and 7. And we're going to have also a target that's going to be 9. Okay, so the first possibility that's not going to be very efficient is to try all of the pairs, try all of the possibilities and see which one is going to be the target. Okay, so I'm going to write all of them down so you can see how big it would become when it comes to bigger numbers, because here we are going to have only 4 integers, but if we had 100, 1,000, a million integers, it would be not very efficient. Okay, okay, so as you can see here, we will have 12 possibilities, 3 for each number. But why 12? It is gonna be 4 squared, that's the total elements, minus 4 because they cannot meet with themselves. You cannot sum the number with itself. Okay, so in the big O notation, it would be an O of n squared, because we do not consider the constant here, or either the smallest numbers. Okay, so the n square would be our number here. So as you can see here, it's not a very good approach, because as the number gets bigger, we will have more and more comparisons to do, and when it comes to n equals 1,000, 10,000, a million, it will be very poor solution. Okay, so now we're going to try a different approach. Let me just erase all of the things we did here. Okay, I wiped out my G. So the second possibility here is if we think about a structure called hash map. I think most of you already know it, and I can think here, if we use the hash map instead of doing all of the comparisons, and we would use a concept that we're going to call here as complement. Okay, and what is the complement? The complement is going to be equals the target minus the number we are trying to find. So let me give you an example. For the number, I don't know, for the number 7, the complement for the number 7 is going to be 2, because it's going to be the target, that's 9. 9 minus 7, that's the number, is going to be equals 2. So if we have a 7 and we find a 2, it means that we found the pair that's going to be our target. Okay, So in this case, we're going to go through all of the array here, and we're going to check for the numbers and try to find its complement. So we're going to look, for example, for the number 11. And in our hash map, we do not have the complement for the 11, because the complement for the 11 is going to be minus 2, because 9 minus 11 is going to be equals minus 2. Okay, so we're going to put here in the set 11 and its index, that in this case is going to be 0. So we're going further for that. Let me just write it down so it's going to be more visually easy to understand. Okay, so the complement is going to be 9 minus 11, which is equal minus 2. Okay, and we're going to do for all of them. Okay, so as you can see here, the first two numbers, they do not have a complement, but the number 2 has a complement that it's number 7, and the number 7 has a complement that's going to be number 2. So as we go down doing this verification here, we're going to eventually find, like when we get to the number 7, which is the worst case here because it is the last number in the array, we're going to check what is the complement for number 7, and it's number 2. And we're going to check in our hash map, do we have number 2? If we have number 2, it's okay. We are done with the problem. Okay, I think you understood that. I'm gonna give you a better example. Now thinking about the code, how could we work it? Because I think it's gonna be very useful for us to structure our algorithm. Okay, so what do we have here? The first thing we're going to do, we're going to go through all of the array. So we're going to have a loop, all right? This loop is going to look for all of them. So the first thing it is going to do is to find its complement. So the first thing, so inside this loop, the first thing we're going to do is find complement. After we got the complement for that number, we're going to number 2. What is number 2? We're going to look inside our hash map. So search for complement. And then we have two options here. If we find the complement, problem solved, it's done. We found the two possibilities, and we are going to return an array with the index of the complement. So it's going to be the hash map, the index of the complement, and the index of the number itself. We're gonna call it I here. Okay, and if we do not find the complement, what we're gonna do is to put the number and its index inside the hash map. So we're going to decide the hash map num. Is gonna be equals the index we have here. That's going to be, we're calling I. I think it's clear. Now I'm gonna show you the code approach here, so we can see how we're going to do it in Python. But for the last part, I'm just going to do a quick comparison here. So before we had an O n squared approach, and now we do have an O n approach. So in this case, we had before 12 comparisons. Now we have only 4. But when it comes to bigger numbers, if we do, for example, for an n that's equal to 1,000, for example, n equals 8,000. We're going to have uh, 1,000 squared comparisons, while here we're going to have only 1,000 comparisons. This is gonna be equal 1,000,000 comparisons we'll have to do, while here we only have 1,000 comparisons. So when it comes to bigger numbers, this is really gonna make a difference. Okay, so let's go to the to the computer and try to do it in LeetCode page. Okay, so now let's go to the code approach here. Let's do it. First of all, we're going to declare our hash map, which is going to be called scene, because we will store the numbers we have already seen. After that, we're going to go for a iteration through the loop, and we're going to get the index and the num itself, and enumerate nums. That's our array. After that, we're going to find a complement for that number. The complement is going to be equals the target minus the num itself, and if the complement is in the scene array, we're going to return an array, which the first one is going to be the index of the complement, so it's going to be scene complement, and the current index we're of our current number. Okay, when we do it here, and if we do not find it, if we do not find a complement in the hash map, we're going to do scene num is going to be equals I. So we're going to put this inside of the hash map. Okay, let's run it once to see if it's gonna work or if we did something wrong. Yep, seems like it worked. Let's submit the problem. There it is. We did it. I think this approach is really interesting. I found out about it recently, and I thought it was a good theme to bring to you guys. I intend to keep recording these kind of videos, solving problems, LeetCode problems especially. I think that's all for today. Thank you so much for sticking up to the end of the video, and I'll see you in the next one.